So for the next part of the experiment, we're going to use a mirror. And you'll see here, this is a very tiny mirror. I'm just going to turn it around. And what you'll weirdly see is there's the camera, but you can't see me. And that's because over the quarantine period, I actually got bitten by a bat. And since then, I've gained all kinds of eerie powers, including the ability to bite people really well, and invisibility in mirrors, so I don't know what's going on. But what we want to do is just set the mirror up so it's roughly at the same height as the lens. So you can see that there it's a little low, so I'm going to raise this up. I want to make sure that there's enough of the mirror exposed so that it's going to reflect back. Now I'm going to hold it this way for now, but later on if I need to, I might switch it so that we get a lot of the mirror through. Now, we also don't want the mirror being perfectly parallel, so I'm just going to give it a little tilt, because the idea with the next part of the experiment is I'm going to have a light source shining through here. It's going to reflect off the mirror, travel back, and we're going to find the point at which it's focused. So we call this the autocollimation method, so I'll let you read up on the theory about that there. But let's get the bulb set up. So I'm actually going to need two optical bench slides here. So let me put the first one on. The first one isn't crucial in terms of where it's positioned anyway. We don't really care about that. So I've put the two optical bench slides on. One of them you can see is a very disparate height, so let's fix that. The unfortunate thing with students doing these experiments is they do not do a good job, and it's meant I've had to fix loads of stuff I've found that they messed up and then abandoned, so it's quite annoying. Anyway, there we go. So the first slide that I've put in, I'm going to just clamp basically this cardboard screen in. So it's just thin cardboard with a hole cut in it. And the idea is the bulb's going to shine through, and that's going to give us it'll give us less light kind of being coupled into the lens, which should make things a little more easy for us to kind of get focused and so on. But also I'm going to project, so the light's going to shine through the lens, reflect off the mirror, come back, and we'll see the reflection somewhere on this screen, and we're going to judge the point that it's focused, and that's going to help us find the focal point. So that's roughly the right height. Again, until I've put everything in place, it's not much point in finally adjusting anything. So we'll leave that for now, and then this is the next thing I want. So this is very simple, just a little bulb. Just a little bulb in a holder. And I can mount that into the bench too. I've got these kind of red and black Harley Quinn style power cables. Okay. So what's immediately clear to me, and should be to you, so there's a bit of a horizontal misalignment there, so let's fix that first of all. So again, I'm just going to move this over a bit so that it's roughly shining down. Now, the next thing I'm going to do is I'm going to put this power supply on, but these bulbs will blow well below the level of these power supplies. And so this is a thing you can hold over the year above you. They blew a lot of bulbs, like more bulbs than any group's ever blown before. So I'm actually not going to connect the lamp until I've put the power supply on. Okay. And then I'm just going to dial both these things down so that they're, as low as they can go. So you can adjust the voltage with this one. It won't do anything at the moment because nothing's connected. And you can adjust the current with this one. And again, just making sure both are down at the lowest value. And, red and black, red and black. So hopefully not too difficult to figure out which goes where. Okay, so now we find out if this light bulb is working. Not bad. I'm tempted to blow the bulb just so that you can see what happens when you do, but I've not been able to find any of the replacement bulbs, so this is the only one we have in the Department of Physics. So how many physicists does it take to change a light bulb? All of us, because there's no replacement, and we'd have to go on the streets and hustle to try to afford to buy some. Just picture me down by Union Square, dancing wildly in front of the train station, gyrating like a madman. My very, very fleshy body corpulently flailing around until people gave me money out of pity. I think you'll agree with me, it's not a pretty picture. So let's not. Okay, so let's shift position and we'll have a look and see how our alignment's doing. Okay, so crucially, this position, the position of the mirror, doesn't matter. It just makes things either easier or more difficult. So I'm going to move it out of the way for now, and you can see there's the light kind of coming through. It's about centered, so we're doing all right here. I'm going to move this up. Okay, and I think I'm going to raise this just a little. Not too much. That looks good to me. I'm just looking to make sure there's light coming through centrally, so let's have a look. Beautiful, right? So as I was saying, it's just easier to align, because the important thing with this, so the light comes through, strikes the mirror, reflects back. And if I have this way up here, then I'm sure you can imagine this, but the change in, I'll move it down, the change in mirror position that gives us the change in angle is very small. So a small change in the angle of the mirror will give us a big sideways displacement of the image. That's not quite as bad the closer we are, so I'm just going to set that about here. Raise up a little, but I can see it's kind of reflecting now, so that's good. And then just a tiny sideways tweak. And there we go. So let's have a little look at what I'm talking about. So what I want you to look at is here, this, and that's the reflection. That's the reflection of the filament. And I'm going to just very finely adjust this now. And you'll see it gets sharper and sharper. And then it gets worse and worse. So I want to find the position that it's sharpest. I don't think you'll capture this on the kind of camera, or I don't think I'll capture this on the camera, so I'm going to have to judge this, and then I'll take a photo of the position. So I'm just sliding this and watching the filament change. It's quite blurry there, and that's its sharpest point there. One good trick when you're doing this is to kind of take it too far one way and then too far the other, and then you kind of judge the midpoint where it focuses. But I'm happy with it there, so I'm going to take a photo of the position. And that will allow you to calculate, using the difference between the two, that will allow you to calculate the focal point. Now, we need both focal points. They'll be different depending on which way we're going through the lens system. So all I need to do now, I'm going to move this out of the way so that I have space, but I just need to swing this round so that we're going the opposite way. And then just going to do the same thing. So this is going to go up here. And yeah, again, I'm just going to finely adjust until I find the point where it focuses. It will be different. It won't quite be at the same point. And I'm going to have to just subtly readjust some of the features. There we go. And for me, that's focused there again. So I'm going to take another photo of that, and that will give you your other measurement you need.